This is the third lecture for the ME 760 at the University of Waterloo. We're going to explain a few things on the Monte Carlo approach. We need that for risk assessment, and it doesn't suffice just to use very good tools, Excel spreadsheets, add-ons to Excel spreadsheets, but we need to understand the basics, how these things really operate. And we're going to use the calculations of the number pi, remember 3.141592, using the Monte Carlo approach. And this is done by getting a square and putting a circle that exactly matches the square inscribed inside the square. And the approach here is that the probability that we will generate randomly that falls inside the circle is proportional to the area of the circle in relation to the area of the square. So we're talking about the area of the circle and the square. And I remind you what is the area of the square, which will be the diameter squared, and the area of the circle, which is pi d squared divided by 4. So now we will use the probability that it is inside the circle, which is the total number of points inside the circle divided by the total number of points inside the circle and outside the circle, but inside the square. So to accelerate the explanation, I already wrote here the import of the libraries. This random will generate our random numbers. And what we're going to do then is, in the Monte Carlo, we will need to generate a few realizations. And what we are going to use, I'll call the variable just sample size. These are the realizations that we are going to use, and I'm going to use just 100. And then we're going to say inside hit. So I count how many of the numbers that I'm going to randomly get inside the circle, and I set it to 0. And now I can start randomly generating points. I'm going to generate the x and y for each point. So what I will do is this. I will do a loop for I in range of my sample underscore size, colon, and I say x equals, and this is how we generate the random number, random dot random. And the y is also a random that I need. This will be equals to the same random dot random. It will generate a random number between 0 and 1. So then I must assume that my radius is 1. I can do the same thing with any size radius. I'll show how it is done in the course website. Let's say if. Now you know how to find out using Pythagoras, how to find out if that point is inside the circle or not, just by doing if x squared plus y squared is smaller than 1, the radius, then what we do is inside hit equals the previous inside hit plus 1. There is an effective way to do this, but it's not as clear, so I'm not teaching here. It would be inside hit plus equal 1. What it does is the same thing, but it's clear the way I did outside the comment. So all I have to do now is pi Monte Carlo equals inside hit divided by sample times 4. Now we need to print. So to know what is pi MC. So I say print pi MC for Monte Carlo equals, comma, pi MC. I'll have the numbers right here. So I will run, and pi MC 296. I did just with 100. It's not bad. It's 3.14. Now if I do 10,000, and I run this again, 3.14. So this is already pretty good. The code that I made available at the course website has the complete explanations of every step, and it's something I recommend that you look, because I want you to change the sample size and see how the accuracy improves using the Monte Carlo approach. That's it for today. Feel free to email me with any questions.